All right, Algebra 1, hope you're excited. I'm super excited about this first video for you. We're going to start out with rational and irrational numbers. So we're going to kind of bypass a little bit of the equation stuff that is typically the first thing you would learn or relearn in math. We'll get to that, it's fine. But I want to talk about rational and irrational. I know the projector light is probably right about there. That says numbers. All right, we'll get it. So very simply, an irrational number is a real number that cannot be written as a simple fraction. What does that mean? Well, it means that it can't be written as something as easy as this. So for instance, 1.5, that's a decimal, but I can write that as a fraction or a ratio of 3/2. Very simply put, it's something that can go over to a decimal very easily. Now, for instance, our first irrational number is pi. It should be one that you already know of. And why is it irrational? Well, I can't represent it as a fraction. I can't represent it as a ratio. Whenever you feel like you're in trouble with these types of things, like if you're not sure if it's irrational or not, put it into the calculator and see what it gives you. For instance, I'm putting in pi right now, and what it's giving me is 3.141592654 blah 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 blah. When it goes on forever and never repeats, it is irrational. Now there are a lot more irrational numbers than you think of, right? I can think of about 15 off the top of my head. We're not going to go that deep with it just yet. So, first example of rational and irrational, okay? 7, what do you think? Well, we're talking about simple fractions. 7 is pretty simple. I can do 7/1. Any integer, I can put a fraction bar and a 1 underneath it. That means it's rational. Very cool. Next non-example of a rational number, the square root of 2. The square root of 2, again, I don't really know. I'm going to put it in the calculator and see what it gives me. So the square root of 2, 1.4142135562. It is going to go on forever. No repeating, no terminating, a bunch of nonsense. This is another irrational number because I am not able to make it into a ratio. Last example for you here, 0.33. This is actually should be repeating. You already have an idea of at least that percentage, right? But you can make that into a fraction, and it's 1/3. Okay, it is rational. So rational. Okay, over here, square root of 3. Not so sure. If I put it in the calculator, it's going to give me some nonsense, just like this one. It's the same thing. It's irrational. And if you saw how this kind of works, this is how I'm rolling with it. Okay, so simple fractions, integers with 1s underneath them, whatever. Moving on. I want to revisit some decimal types, and I know you probably already know this, but this is going to be helpful for this unit, at least the first part. We've got repeating decimals. Okay, so we just did 1/3, right? It's going to repeat forever and ever and ever and ever. Tell me when to stop. Got it. Heard you. Terminating. Let's go with the typical one, 1/8, right? So 0.125. Bam. It stops. It terminates. It doesn't go any further. Both of these are what type of number? Yes, they're both rational because this one is repeating, but I can represent it as a fraction, right, a ratio, and this one is terminating, different than that, but I can still represent it as a fraction. I can represent it as a ratio, rational ratio. Okay, non-repeating or terminating. This is where it gets kind of irrational, okay? So if it's not repeating, so it does some other nonsense, or if it's not terminating, it does something else. Think of pi. Pi is like the universal one that everyone knows of. It is irrational. It keeps on going. It has no pattern, and it just goes on forever. Good. Let's move on. Trying to keep this first video not 10 minutes for you. Let's do a couple of examples. Now, you didn't think it would be that easy just to identify rational and irrational. We have to do operations with it. So operations are what now? This is math class, yeah? Okay, so we're doing adding, subtracting, multiplying, and dividing. We're going to hold off on dividing because that gets real messy in a minute. Example 1, 8 plus root 5. Well, we need to identify whether this is rational or not. I know 8 is rational because I can represent it as a fraction with a 1 underneath. Root 5, however, is irrational. So we need to come up with some kind of a law. But first, let's try the example. Whenever I add a number that's rational to a number that is irrational, my answer is going to be irrational. Now think of it like this. If you were to put the square root of 5 into your calculator, you would get 2.23 and a bunch of other numbers underneath it. That's fine. So let's just do 2.23 and make some dots to know that it's going to be irrational. It's going to go on forever, no repeating or whatever like that. If I were to add 8 to this, I'm adding 8 just to the front, right? To whatever is to the left of the decimal. I'm going to get 10.23, but guess what didn't change? All that nonsense behind it. That stuff behind it is what's making it irrational. So when I add a rational to an irrational, I'm always going to get an irrational number. Bam, done. Moving on. What do you think the rule is when I subtract? Waiting for you. Got it. Okay, I think I heard somebody. Good. It's going to be the same thing. I'm just subtracting 13 from the number that is in front or to the left of the decimal. So if you were to put the square root of 7 in there, you'd find out very simply that it's still going to be irrational. Next one. Think about it. You are right. It's rational. And here's why. The square root of 36. We know what that is. It's 6. So 6 plus 11 is 17, which is definitely rational. Next one here, really super challenging. We'll come back to that one later. I want you to try that on your own. All right, I think I got one more for you. I lied, maybe 2. We're just going to do 2 of these and we'll move on. Example 5, the square root of 8 times 10. I'm going to do these parentheses. It's going to be a little easier for me. Okay. The square root of 8 is irrational. 10 is rational. When I multiply these two together, I am going to get an irrational number. So a rational times an irrational is going to give me irrational numbers. I'm just going to do right now. And number 6, we'll stop after that. The square root of 2 times the square root of 2. Now, we'll get to the rules with multiplying and operations with radicals in a little bit. Not today, though. When I multiply these two together, I am definitely able to multiply them. So when I do that, I get the square root of 4. Okay? What is the square root of 4? Oh, yeah, it's 2. Well, 2 is a rational number. So, the big takeaway here. Irrational times rational gave me a rational here. But that's not always the case because sometimes things change within the context of the problem. Irrational times irrational gave me a rational number. Okay, and we'll work more on that in a minute. Wow, that is a big multiplication dot. I didn't think it was that big. Okay, let's talk about a couple of very simple rules and we'll move on from there. Number 1, the sum or difference of a rational and an irrational number is, and we just did an example a minute ago, it's irrational. Okay? The product of a rational and an irrational number is, okay, let's make sure we use a math terminology, the product. Okay, so we're talking about multiplication. It's irrational. And the product of 2 irrational numbers, we just did another one, well, we got a rational number, but that's not always the case. So we're going to put a big question mark there because that's the one where you're going to have to actually do the multiplication over and over again because it's going to change from here to there. Now, for your kind of assignment, for the paperwork I'm going to give you, can you think of any more rules? Can you make a significant rule for these types of things? Because we didn't cover all of them. And are there any? Kind of just hinted that there were more. We'll talk about it tomorrow. Hope you liked the video. I'm out.